So far, you have learned about sequences, you've learned about two special types of sequences, and then you also have learned one way or another way of writing a sequence, which was the recursive form. So today you're going to learn another way of describing or writing a sequence, and that's called explicit form. So, and it is another way of writing it kind of in an equation type form, okay? And so, but explicit form is a little different than recursive form. So we're going to talk about that. So before we get too far in here, first thing you need to know is explicit form could be called also closed form, okay? So you need to know it by both names. But something else I want to kind of remind you of so that you can see the difference here is remember to write a sequence in recursive form, you have to know the previous term and you have to know the pattern, because remember, to write the recursive form, you're kind of asking yourself, what do you do to the previous term to get the next term? And so those are two things that you have to know to be able to write something in recursive form, okay? So now the good thing about explicit form is it kind of stands alone, meaning you do not need to know the previous term. And there is a reason for that, okay? Because explicit form is not actually based on the previous term like recursive form is, okay? Well, then what is explicit form kind of dealing with? Well, there's actually two good things about explicit form. Number one, explicit form is going to allow you to find any term in your sequence. So that's a really good thing about explicit form. And the reason for that is because it's actually based on the position of your term. So now remember, position of the term is kind of like where that term is in your sequence. Is it the first term, the second term, the 50th term, the 10th term? And so the reason why explicit form is so good to have when you're looking for terms in a sequence is because it is based on the position. All you have to know is which term you're looking for, and you will be able to use this equation that you write to find it. So like if I asked you to find a sub 100, or in other words the 100th term in your sequence, all you're going to have to do is plug in 100 into this equation and it will tell it to you, okay? Whereas if you were trying to use the recursive form, remember recursive form only tells you kind of what you're doing from one term to the very next term. So if I was asking you to find the 100th term in your sequence, we're going to have an issue, because that means you're going to have to do that. Like if you were adding 3 each time, you would have to add 3 over and 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 over again, about 99 times if you're starting from the first term to get to that 100th term, which, as you can imagine, would take a while, okay? And so recursive form is nice because it tells you the pattern. So if you had to find like the 10th or 11th or maybe even the 15th term, it wouldn't be so bad because you wouldn't have to do the pattern so much. But if you're being asked to find a term that's way down the line, you're going to want to use explicit form, okay? So let's just talk about how does explicit form work, and then we're going to eventually get to the point where we're going to actually be finding explicit form, okay? So our first example here says, write the sequence defined by this explicit formula, okay? So I want you to notice a couple things. I want you to notice what is different between this formula, which is our explicit formula for a sequence, and then what we were doing the other day with recursive formula. Recursive formula, remember, you would see the a sub n, and remember the a with a little subscript of an n just means it's a term in your sequence. But instead of seeing an n, what you would see is the a with a little subscript of an n minus 1. The reason why you would see the a with a subscript of n minus 1 is because that would represent the previous term. And remember, explicit form is not based on the previous term, it's based on the position. And so that's actually why you see an n here, is because if you remember, n kind of represents the position of that term, where that term is in the sequence. It's this number right here, that's the subscript here. So like that would be the 100th term in your sequence, okay? And so what we're going to do is practice, okay, if they give you the equation, how can you write the sequence from it? Well, Remember, this is the position, so n is the position of your term. So if you had to write out your sequence, well, if I needed to find the first term, I'm looking for the term that's in position number 1. So I'm going to plug a 1 in for my n. So I would go to the side, and I'm finding the term that's in the first position. And so that's this part. And then I'm going to plug in a 1 right here. So it'd be 2 times 1 minus 1. And then whatever I get for that would end up being the first term in that sequence, okay? So notice it's not based on the previous term anymore. It's based on just whatever the position is, okay? And so when I simplify this, it'd be 2 times 1, which is 2, and then 2 minus 1 ends up being 1. So the first term in this sequence would be 1. So to find the second term, I'm going to do the same thing, but this time I'm looking for the term that's in the position number 2 in my sequence. So I'm finding the a sub 2 term. So I'd take 2 times 2 this time. So I'm plugging a 2 in. So I just noticed I plugged the 2 into my equation, and then I'm going to simplify that. So that'd be 4 minus 1, which is 3. So the next term in my sequence would be 3. And then I'd keep going for however long I needed to keep going. Now, this doesn't tell me how many terms to write out, so I'll write out about 4 of them. But then you would have your sequence. So the third term, we're going to plug in a 3 into that equation. So that would be 6 minus 1, which ends up being 5. So that would be the third term in my sequence. And then if I needed to find one more, I'm plugging in a 4 because I'm looking for the fourth term in my sequence. So it'd be 2 times 4 minus 1. And then that would be 8 minus 1, which is 7. Okay? And so that is how you use the explicit formula to actually write out the sequence. So now let's look at what's going on. So remember, I told you that the explicit formula is based on the position. So like this term right here would be my first term. This term right here, the 3, would be my second term. That term is my third term, and then that last one right there is my fourth term. So explicit formula is essentially what are you doing to these numbers that give you those, okay? And so that's actually what we're going to move on to is how, like if they give you the sequence instead, what would you do if you had to write the equation? Well, that's what we're going to work on, okay? So again, you're essentially, when you have to go from the sequence and you have to actually write the equation from it, what you're doing is kind of asking yourself, what do I do to these numbers to get the terms in my sequence, okay? And so that, you know, it does take some reasoning to do that, but that's what we're working on, okay? So, and actually, before we move on, I do want to point out something here. Notice what type of sequence this is. So what's the pattern here? If I go from 1 to 3, 3 to 5, 5 to 7, what are we doing? Well, and you'll notice that we're adding 2 each time. So this would actually make an arithmetic sequence. The other thing I want you to realize is if you think back to what we were doing with like linear functions, you'll remember, added that constant number. So this would actually be a linear function. And so you could actually graph these like their coordinates, and you will notice you could look at it like a line as well. And that'll help with some problems if you knew that, okay? So now let's work on, okay, what if we're this time given the sequence and we have to actually work backwards to get the equation? Okay, well, like I was saying up here, you could look at the positions of each of these terms and kind of try to reason through it. So like that would be my n. So like what's the position of this term? Well, this would be the first term. This would be my second term. That would be my third, my fourth, my fifth. And so what you could sit here and kind of think through, and you can pause it if you need to, but you can sit here and think, okay, what could I do to 1 that would give me a 2? Whatever I do there, I have to do the same thing to 2 to get 5. And then I have to do the same thing to 3 to get 8, and then 4 to get 11. And so you can see here and kind of brainstorm, all right, well, if I take 1 and I multiply it by 2, I'll get 2. Okay, so let's see if that works here. If I take 2 times 2, do I get 5? Okay, no, that didn't work, so let's back up and go back to the beginning and rethink, okay? And you can kind of brainstorm different things that you could do to these numbers that would give you that and see which one works for all of them. And that could take a while, okay? And so what I'm going to talk to you about is another way to do it, okay? So if the brainstorming isn't working, okay, then what you're going to actually do first is you're going to figure out what type of sequence is it, okay? So that means that you have to look at the pattern of it. So what's going on from one term to the next? So are you adding a constant number? Are you subtracting? Are you multiplying, dividing? And so you'll notice here, like to go from 2 to 5, 5 to 8, it looks like we're adding 3. And so I'm going to check that and make sure that we're adding 3 each time. So 8 to 11, we would add 3, yep, to get there. And then we'd add 3 here. And so the first thing you do is figure out what kind of sequence it is. And you'll notice that this one, because we're adding the same number each time, that would be arithmetic. Okay? And then you need to realize that there is an actual explicit formula for arithmetic sequences. Okay? And so now I'm out of room on this side, so I'm going to actually flip it. And I'm going to write down the explicit formula that you should know for an arithmetic sequence. So put a little box. So if the sequence is arithmetic, and they're asking you to write down the explicit formula, so this would be the explicit formula for arithmetic, what you're going to actually do, it's going to start out with you're finding a term in your sequence, so that's what that means. So it's going to start out with the a sub n. What you have to do is take the first term of that sequence, and then you have to add to it in parentheses, the position minus 1, and then you multiply times the common difference, okay? So that's the explicit formula. You're going to take the first terms, so that's what your a sub 1 means. Then you add it to, you're going to leave this, if you're just writing the general formula for it, you're going to leave this as it is. And so it'd be n minus 1, and then whatever your common difference is, which remember the common difference is the number that you're adding or subtracting each time. Whatever that common difference is goes right there. Okay, so let's use that formula, because our sequence was arithmetic, to write the arithmetic explicit form of it. Okay, so I'm going to just take that and I'm going to write it down here. So we're going to plug it in this equation right here. Okay, so to find a term in this sequence, I'm going to have to start with 2, and I'm going to add to it 3 however many times I need to get to. Now, let me explain where this part comes from. So like if you needed to get to the 4th term here, well, if I start with 2, I'd have to add 3 how many times? So if I'm trying to get to this one, notice I'd have to add 3, 1, 2, 3 times. And so really I could just take and add however many 3s I had to do. So like I had to add 3 times, so I'd take 3 times 3. And so that's actually where this part comes from. To get to, sorry, my lights just went off. Sorry. To get to the 4th term, you actually only add 3 times. So 1 less time than the position you're getting to. So that's kind of where this formula comes from, all right? So that's why you have that minus 1 there. Some people get confused by that part, okay? So to write the equation, you're starting with 2, and then you're going to add. You leave this part the way it is for the moment because you're not actually finding a term yet. And then you multiply that times, well, what was my common difference? Well, that's the number that you're adding or subtracting each time. So in this problem, your common difference was 3. So there you go. that is actually the explicit way of writing this sequence. Now, we do typically clean it up, so we will be simplifying this most of the time, okay? So that 2 comes down, and remember, you have to do the multiplication first. And so I'm going to have to distribute my 3 because it's being multiplied times that parenthesis. So it'd be 3n minus 3. And then I'm going to combine my like terms. So I get 3n, and then 2 minus 3 is minus 1. So if you were sitting here and trying to reason through, okay, what do I do to 1 to get 2? That has to be the same thing that I do to get 2 to get 5. You should have ended up with something like this. I have to take 3 times this, so like 3 times 1 is 3. And then I had to subtract 1, and that would give me my term, okay? So the reason why these formulas are so nice is now I could ask you to find any term in your sequence, and you could find it super easy. Like if I asked you for the 100th term, so that would be a sub 100, all you do is plug in 100 in for n right there. So you would take 3 times 100 and then minus 1. And so your 100th term, you're going to take 3 times 100, which is 300, and then 300 minus 1 would be 299. So your 100th term of that sequence, if you added 3 over and over and over till you got to 100th term, would end up being 299, okay? That's the reason why explicit forms are so lovely, all right? So let's do a couple more examples because your sequences won't always be arithmetic. And if it's not arithmetic, then you're going to have to use a different formula, okay? So I'm going to flip over, and we're going to do some more examples, okay? So this would be example number 3. So what if you had something like this? You've got 8, or the sequence 8, negative 1, negative 10, negative 19, so on and so forth. And you had to write the explicit form of that sequence, explicit form. Okay, well, just like what you did in the other one, you could sit here and try to reason through it. So explicit form, remember, you're looking at the positions of these terms and you're trying to figure out what you would do to it. So like this would be the first term. So what do I do to 1 to get 8? Okay, that would be your second term. Whatever I do here, I'd have to do the same thing to 2 to get negative 1. This is your third term. That's your fourth term. So your equation would have to work for every single thing. So like whatever I do to this one to get 8 has to be the same thing that I do here to get negative 1, here to get negative 10, so on and so forth. And so that, you know, there's going to be some of you that will be able to kind of think through that and figure out the equation just by thinking through it. But if that doesn't work, then you have a backup, okay? So if that doesn't work, and that's the end, so that's why I wrote the end there. Other than doing that, you could figure out what kind of sequence it is and use the explicit form for that. So figure out the sequence, which means you look at the pattern of it. What am I doing from one term to the next? And so you'll notice it's actually going down. And so think about, okay, am I adding or am I subtracting a number, or am I like maybe dividing or multiplying by a fraction here? And if you think through it, you'll realize that you're actually subtracting 9, okay? So if you're adding or subtracting a constant number, that means that it's arithmetic. So this one's also arithmetic. Okay, and then your common difference is whatever number you're adding or subtracting. So my common difference here would be negative 9. Okay, so since it's arithmetic, we're going to be using this same equation. So you write down, this will be the equation we can use to find a term in our sequence. Then you're going to plug in your first term, and then remember, for the general equation, you leave this part the way it is. And then you're going to multiply times whatever your common difference is, okay? So let's plug in. So my first term of this sequence was 8, so that's what goes here. And then we leave this, so make sure you put plus that part. And then you're going to just multiply by whatever that common difference is. So I would recommend putting this in parentheses because it's got a negative with it and that could mess with you, okay? But that's your equation. So that's one way of writing it. But remember, I told you that we usually clean it up. So if I clean this up, I'm going to distribute my negative 9 because it's right beside this parenthesis, so I have to distribute it. So then this 8 and the plus will come down, and then let's see. Negative 9 times n ends up actually being negative 9n, so that would change to a negative, so minus 9n. And then negative 9 times negative 1 ends up being a positive 9. Okay, and then we just combine our like terms. So the negative 9n is going to come down, and then 8 plus 9 ends up being 17. So this is the equation that you can use to find any term in your sequence. Okay, all right, let's do another one. So what if we had a sequence like this? You had 1, negative 2, 4, negative 8, so on and so forth, okay? And you, again, had to write the explicit form of that sequence, which means what do you do to the positions of those terms to find those terms? Okay, well, again, you can think through it. So, like, what do I do to 1? That would give me a 1. What do I do to 2? That would give me a 2. A 3 to give me 4. A 4 to give me negative 8. And I will be honest, this one will be a little harder to reason through just because of the way that the sequence is, okay? And so, if that's not working, the reasoning side is not working, then what you're going to do is figure out the pattern, and then you're going to use the explicit formula that goes with that type of sequence, okay? So what's the pattern here? What are you doing to go from one term to the next? If you're thinking adding and subtracting, well, to go from 1 to negative 2, or in other words, remember, you could do this to the side, take 1 minus the other one, and you'll notice that you're subtracting 3. But if you take negative 2 minus 3, it's not going to give you 4. So that means that we're not adding or subtracting, which means it's not arithmetic. So then check to see if you're multiplying or dividing. And so what would I multiply 1 by to get negative 2? Well, I'd have to multiply by negative 2. So let's check that. If I take negative 2 times negative 2, I get the 4. So that works there. And then if I take 4 times negative 2, do I get negative 8? And yes, I do. So that actually means that this one is a geometric sequence. And so your geometric sequences, remember, don't have a common difference. They have what's called a common ratio. And so the common ratio would be whatever number you're multiplying by, which in this case would be negative 2. Okay? So now, to write the explicit form, you'll notice that it's a totally different kind of thing going on. Like here, I talked about earlier that these are your linear functions. Anytime you're adding or subtracting, it's linear. Notice that is a linear equation. If you think about this as like an x, that's a linear equation. That's your slope, that's your y-intercept. I know, it's crazy, right? How everything relates. But this one, when you're multiplying, if you think back to what we did, this would actually be exponential. And so this equation is going to be a totally different equation, okay? So now, that would be the explicit formula for an arithmetic sequence. Now we're going to write down what the explicit formula would be for a geometric sequence, which will be a completely different thing. So geometric explicit form. Okay, well, geometric formulas, like I said, are going to be exponential. And so this one, you're still going to use it to find a term, so that part will be the same. But for this one, you're going to actually start by putting your first term times whatever your common ratio is, and then that part of it will be to the n minus 1 power. And kind of like whatever here, we talked about where that came from. It's similar here because if you look, like if I was finding the third term here, I'd only have to multiply by negative 2 twice. And so you're multiplying by that common ratio one less time than whatever term you're finding. Okay, so that's where that comes from. But to write the explicit form of a geometric sequence, you're going to take your first term, plug it in, and then you're going to take your common ratio, which is the number that you're multiplying by, and plug that in, and then you just write that part out, and that would be your equation, okay? So the explicit form, we're going to plug it in this equation, okay? So
we have the drawing of our homemade soup, and the winner is Miss Whittington. Congratulations, Miss Whittington. You can pick up your soup in the front office.
So, sorry about that. So you're just going to plug in your first term and your common ratio. So my first term in the sequence would be 1, so that's what goes for that. And then my common ratio is -2, because that's the number I was multiplying by. And then you just leave that n minus 1 the way it is. Now with this one, what you're going to want to do is multiply these two numbers. But remember, you can't actually do that. If you think about the order of operations, you have to do the exponent part first, and this -2 is with that exponent. So until you could simplify this part, you cannot multiply those two numbers. So please, please, please stay away from multiplying those. You'll mess it up if you do that, okay? So that would be your form. And if I asked you for a term in the somewhere in the sequence, like the 50th term, you would take 50 and plug it in right here and simplify that, and you will find the 50th term, okay? So that is how you write explicit forms of different types of sequences.